Welcome to the course of wireless sensor networks. This is lecture number 16 and I am your instructor Zeeshan. In the part 1 discussed in lecture number 15, we were considering different scenarios, different protocol scenarios in the network layer. We talked about some data-centric protocols in the network layer like data diffusion, spin, rumor routing, and we discussed some pros and cons of each protocol. Then we discussed a different category of the network layer protocols, which is the hierarchical routing, and we discussed that hierarchical routing are good in terms of implementation. However, when we consider it for wireless sensor networks, so it consumes a lot of energy and it introduces delay in the network. So this is part 2 of the topic, that is network layer, and let's move to the agenda item for discussing some more protocols. So the agenda item for discussion will continue from the hierarchical routing protocol, which we were discussing in the part 1 of our topic, and then we will discuss another protocol, a hierarchical protocol, which is a leech protocol. We'll be discussing some setup related issues and then the state management issues. Then another important protocol, that is the PEGASIS. We'll be discussing that thing, and then the TEEN protocol, and at the end we will summarize our today's discussion. So let's move and complete our discussion that is related to the hierarchical routing protocol. So we already talked about that in our previous lecture, that is lecture number 15, that hierarchical protocols are very good when we talk about the implementation, or talking in terms of the implementation, because with every layer the complexity can be reduced. However, it introduces latency because different layers are involved, and overall network performance may be degraded. However, in case of the very complex and very large network, you can introduce some optimized model by implementing some cluster level architecture, in which the different clusters, the hierarchical architecture be divided into different clusters with different cluster heads that are responsible for their clusters, and then there is a cluster head intercommunication, and some sort of routing protocols are implemented between the intercluster heads communication, and and within the cluster some routing mechanisms needs to be implemented, that may be a data driven protocol, that may be an event oriented or a query based. So that depends upon the scenario. However, why we introduce hierarchical routing protocol, and the only feasible reply may be that when the density of any network, or particularly the sensor network, increases, then in order to uh, lower the complexity, so this hierarchical model or the hierarchical routing protocol is feasible. So similarly, in case of the gateway that increases in order to communicate with other network, so this is also one of the solution. However, as we already discussed, that this type of model and the routing protocols increase latency, and it will consume more energy, and which is again a main concern in case of wireless sensor networks. And we also talked about that cluster networks always allow coverage of large area of interest, and additional load happens, and there is always need that all these mechanisms should be addressed without degrading the performance. So this is a challenge. So the idea is basically that we need to partition the complete network into some regions or clusters, and then we have to select one or more nodes as a cluster head, and then the routing is node routing is the node that the cluster head communicate with cluster B, and then the cluster B communicate with cluster C. So there is inter-cluster communication, and then we need to implement some protocols like BGP or OSPF that usually we discussed in traditional network, used for inter-gateway communication or inter-gateway routing. So that needs to be implemented between the cluster heads. So that will help to resolve some issue, that is the energy wastage that happens in collision, and then we can avoid that collision, and then in an ideal listening mechanism. So we need to achieve this can help to achieve better scalability, and it helps to reduce the load on those nodes that are left with very low power, or are not so much computationally powerful nodes. So the second agenda item which need to be discussed as sort of a hierarchical protocol is the leech protocol, and the leech stands for that low energy adaptive clustering hierarchical protocol. This type of protocol is implemented in most of the wireless sensor networks, even though that we already discussed that hierarchical protocol uses more energy. However, the optimized version of leech protocol can be used. They can be used for routing, similarly for security implementation, or for the key exchange, or for any intrusion detection. So an optimized or the improved form of that leech protocol can be used in wireless sensor network, and that exists in research, and some of the good research have been implemented using this protocol, that leech protocol, which is a hierarchical protocol, in implementing any idea that's related to a security mechanism, or a routing mechanism, or a data aggregation mechanism. So what happens in this type of protocol, that this leech protocol tries to self-organize for a large number of nodes. So it divides the whole network into a group of some clusters, and then cluster heads, and select these clusters, and then start communicating within the cluster and between the cluster heads. So a leech steady state, it is broken into some frames where some nodes try to send their data to the cluster head. At most, the data send is once per frame during the allocated transmission slot. The cluster head receives all the data of the cluster, and then this cluster head is responsible for doing data aggregation. So the data aggregation mechanism is localized at the cluster head level, and that cluster head performs data aggregation of all the nodes within its cluster. So as the diagram is shown, in which there is that setup state which starts, and then the frame is sent during the allocated transmission slot, and then there is a round time. We already discussed it. The PEGASIS protocol. PEGASIS stands for the power efficient gathering in sensor information systems. So the key idea in PEGASIS is to form a chain among these sensor nodes, so that each node will receive from and transmit to a neighbor node. So it basically covers the drawbacks that were in leech protocol. And the concept is basically lie on the word greedy, be greedy. So align with the one that has the maximum signal strength form a near optimal chain, and then it tries to communicate with the neighbors only. But who take care of the communication to base station? This is the question that needs to be addressed. So this is the leader protocol. The main idea in Pegasus is that for each node to receive from and transmit to the close neighbors, and take turns being the leader of the transmission to the base station. So the nodes take turns transmitting to the base station, and the Pegasus have another concept of passing the buck, that the token passing approach has been used. You can just look at the diagram that the token is passed to different nodes and also to the base station, and the base station is basically responsible for collecting the data. So the token is passed to from one node to another node. And then we have that TEEN protocol. TEEN stands for Threshold Sensitive Energy Efficient Sensor Network Protocol. Now, when we talk about any type of application design for wireless sensor network, so you have also noticed that whether it's a security mechanism, or whether it is any routing mechanism, or whether it is any data aggregation mechanism, so the energy efficiency word is always been used, because we do not want to design any model or any protocol or suggest any protocol for any application or a scenario that reduces the life of that network, or the lifetime of that sensor networks. For example, if we are using very effective routing protocols, that performs very intelligent decision in terms of routing, and then and we try to implement it on 1,000 sensors, and we want that this application needs to observe any phenomena, for example volcano observation or roof cracks observation, and that sensors needs to be deployed there for a couple of years. So if we embed these protocol into the operating system, or into these sensors, and these sensors are deployed in that roof or in that volcano once, maybe it is these are thousands of sensors, and what happen if that sensor is halted or consumes its all energy within a month's time or within a few months time? So the effort of redeployment and the cost of redeployment will be very much troublesome. So the better decision is that, or the better consideration is that the lifetime of the network needs to be considered whenever any protocol is designed or suggested for any sensor application. So another aspect we discussed is that with there are some networks that continuously grows with respect to time. For example, these networks have um, hundreds of sensors, but within in a couple of months, these number of sensors, the live sensors, increase from some hundreds to thousands, and to some thousands to some lakhs. So in that case, the choice of the protocol that cannot manage so much so large network, whether in terms of memory storage or routing, that will create a bottleneck, that will introduce delay in the network. There will also always be a congestion in the network, and the packet will not reach its destination well in time, or maybe destroyed on the way on the path. So overall performance of the whole network will be degraded. So one of the protocol is the TEEN protocol, that is the Threshold Sensitive Energy Effective Sensor Network Protocol. That's also the protocol for the network layer, and it's basically again an improved version of leech. We can call it a proactive protocol or a proactive version of the leech, and the nodes in this network or the protocol that is implemented in which type of network periodically switch on their sensors and transmit sense the environment and transmit the data of interest. So basically there is no event occur, but a specific time interval has been defined. The sensors normally is in sleep state or a suspended state. So after some period of time the sensors wake up, it collect data and then it sends it. So this can help to effectively manage the energy, so that will increase the network lifetime. Leech is basically a proactive type of protocol. However, the threshold sensitive energy effective sensor network protocol is a reactive protocol that the node react immediately to sudden, and it drastically changes in the value of a sensed attribute. So this is the difference between the proactive leech protocol and the currently which we are discussing, the teen protocol. That in the teen protocol, uh, if there is any change observed in the attribute of the data, so the node immediately reacts, and the reaction is sudden. However, in case of leech protocol, the normally it's a proactive protocol. The nodes lie in a suspended or in a sleep mode, and whenever after a particular period of time, it wake up and observe the data and transmit it to the sync node. So the function of teen protocol is that at every cluster change time, the cluster head broadcasts it to its member. There is a hard threshold HT. This threshold is HT is basically for the sensed attribute, and it's the absolute value of that attribute beyond which the node sensing the value must switch on its transmitter and report to its cluster head. So it's basically this threshold defined when the transmitter needs to be open or when to transmit or report to the cluster head. And then there is another function which is a soft threshold ST, and if there is any small change in the value of that sense attribute, it's not large, it will trigger the node to switch on its transmitter and it transmitted. So the first time a parameter from the attribute set reaches its hard threshold from the soft threshold value, the node switches on its transmitter and sends data. So the transmitter is not open for communication all the time, but there are some threshold or the values or the parameter values that decides that when the transmitter needs to be open and when it is to be and communicating with the sensor node or with the neighboring node. The sense value is again stored in an interval variable in the node, and that we can call in an SV or a sensed value. And the nodes will next transmit data in the current cluster period only when both the following conditions are true. And the first condition is that the value or the current value of the SV is greater than the hard value, and the second condition is that the current value of the SV differs from SV by an amount equal to or greater than the soft threshold. So this is the mechanism. However, there are some drawbacks that if for some reasons the thresholds may not reach, so there will be no communication and the user will not get any data from the network at all and will not come to know even if the nodes die at adaptive period teen. So this scheme practically implement will have to ensure that there are no collision in the cluster. That has to be considered, that there is no collision of the clusters. And we discussed about hierarchical protocol, some challenges. We talked about the proactive leech protocol. Particularly we discussed about the steady state and how the sensor nodes are in sleep mode, and then we discussed the reactive PEGASIS protocol, and then the very intelligent teen protocol, in which the based on the SV value and the threshold value, whether it is a hard or soft, is set, and then accordingly the transmitter to transmit data is open for transmission. So this is the reference from which the content has been taken. So you can just consult it, and for the more information will also be shared on the WhatsApp groups. So with this, thank you very much for patiently listening. Take care. Allah Hafiz.